In a controlled environment, an artificial intelligence can look flawless. Inside this closed loop, students answer questions correctly, and administrative dashboards glow green. Every internal metric indicates mastery of the subject. The failure occurs the moment the student steps outside that loop. Confronted with a slightly altered real-world problem, they cannot apply what they supposedly learned. This suggests the system was measuring a narrow, isolated proxy for success, rather than actual understanding. An algorithm optimized for a sterile lab cannot account for the variables of an unpredictable environment. Deployment is often driven by a single assumption, that a mathematical model proven in one industry can be copied and pasted into another. This approach treats distinct human industries as if they were identical, empty containers waiting for data. But a domain is a living ecosystem with its own rules of survival. Every domain possesses distinct forms of evidence, specialized vocabulary, and specific human fears regarding the outcome. The high-stakes unpredictability of a hospital or a farm shares very little with the controlled conditions of a technology lab. The environment itself determines which information matters. The technical blueprint is secondary. A universal model will break unless it submits to the specific evidentiary rules of the world it enters. A clean spreadsheet might show a drop in crop yield, but it cannot show the farmer standing in a flooded field. The spreadsheet is merely a trace, a record of a past event captured long after the weather changed. If an AI relies entirely on that delayed data trace, it produces recommendations based on a version of the field that no longer exists. Actionable proof changes depending on the domain. What works as evidence in a database fails as evidence in the dirt. Standard AI design typically optimizes for the convenience of the person typing the prompt. This creates a blind spot for the affected person, the bystander who absorbs the actual impact of the system's output. When a teacher asks for a quick summary, the invisible student may receive a permanent, unreviewed learning label that dictates their future. When a manager requests efficiency, the warehouse worker pays for that optimization with an accelerated physical pace. This risk is embedded in the language itself. Vocabulary operates as a mechanism of action. The word recommended is a safe prompt for retail inventory, but in a medical or financial context, it acts as a life-altering trigger. Every AI output functions as a lever of power, frequently harming those who are excluded from the immediate user loop. We must halt the deployment process before a single line of code is written. This requires an architectural framework called the Domain Adaptation Canvas to force a systemic pause. By isolating blocks for memory, review gates, and escalation protocols, the canvas forces the builder to define the domain's unique constraints. The engineering focus moves from what the AI can do to a more vital question: what must the AI refuse to do? Responsible design creates intentional friction, forcing the machine to stop and defer to human judgment. By forcing a builder to define evidence through the lens of a teacher, the canvas reveals that learning is visible in erased attempts and misconceptions, not just a correct answer. In personal knowledge, the review block defines the system as a tool for the active transformation of the human mind, rather than simple data storage. Applying the risk block to operations reveals that local supplier delays and timing are more critical to the decision than historical dashboards. In agriculture, the requirement for field humility turns satellite imagery into a suggestion that must be confirmed by the farmer's physical observation. Crossing domain boundaries requires a system to abandon its universal assumptions and adopt the specific evidentiary rules of each new world. The ideal of a machine making fully autonomous decisions is a liability. True intelligence recognizes its own boundaries. It respects the evidence of the domain and pauses at the edge of its own capability. A super agent reaches its highest utility when it hands the final consequence back to human judgment.